Hello students, welcome to Edubbey Global Solution. Again in our mathematics class, we are going to be looking at another topic which is perimeter, area and volume. Under this class, we're going to be looking at perimeters of some shapes, area of some shapes, and our next class we're going to be looking at surface area and volume of shapes. So the shapes we're going to be considering here is going to be we're going to be looking at triangle, trapezium, parallelogram, then areas and circumference of a circle. Okay, we have interactive content here that will serve as a guide for this class. So let's start with perimeter of a rectangle. The perimeter of a shape is its distance around the outside of that shape. So if we want to measure any perimeter of any shape, we have to measure the distance around the outside of a given shape. Now we have a perimeter of a rectangle here. Let's look at it. A rectangle has what? It has two sides of length and two sides of breadth. Okay, so we cannot say that perimeter can also be measured. We can measure perimeter in units. We looked at measurement in our previous class, so we can use a unit like millimeter, centimeter. Then we have meter, okay, and we have kilometer. So we can measure perimeter in such units. Okay, so for us to measure or calculate the perimeter of a rectangle, we use this formula, which is what? The length here, okay, plus the breadth here, plus the length here, plus the breadth here. So by the time you add up, you know that this is going to be length plus length, that is 2 length, right? Then breadth plus breadth will give us 2 breadth. So by the time we arrange that, then it's going to be 2L plus 2B, where our L stand for length and B stand for breadth. We can actually bring out 2 and put L plus B into the bracket, and that's the formula for calculating perimeter of a rectangle. Okay, we are right with the arrangement. Now let's look at area of a rectangle. But before we go there, let's look at the definition of an area. The area of a shape is the amount of surface that it covers. So for any given shapes, the area of that shape is the amount of surface that it covers. So we can also measure area of any given shapes in the units, like when we have meter, millimeter, we can measure it in millimeter, we can measure in centimeter square, we can measure in meter square, and we can also measure in kilometer square. Okay, so remember with area of any given shape, the unit measurement should be in square. Okay, so if we have a rectangle here, we have 2 lengths and we have 2 sides, which is the breadth here. So if we want to calculate the area of a rectangle, it's going to be L times B, which is what? Length multiplied by breadth, and that's the formula for calculating area of a rectangle. Now let's look at the next activity that we have here. We are given this activity, we have to calculate the breadth of a given rectangle with the area to be 200 centimeters square, and the length is what? The length is 25 centimeters. We told us earlier that the formula for calculating area of a rectangle is what? Length times breadth. So in this given equation, we are this problem rather, we have been given the area to be 200 centimeters square, and the length is what? 25 centimeters. So we have to calculate the breadth. So what we just need to do is we divide this side by 25 centimeters so that we can have our breadth. Divide the other side by 25 centimeters. 25 centimeters comes to 25 centimeters here, so we have B left here. How many times can 25 goes in 200? That is 8. And remember, one of the centimeter will go, so we have 8 centimeters. And that is the breadth of that rectangle. So let's fix the right answer to the boxes. The area of the rectangle is L times breadth. Okay, so if you have to solve the problem, it's going to be 200 centimeters square equals to 25 times breadth, and 200 divided by 25 will give us 8, and that's the breadth of that rectangle. Okay, now we want to look at another area of the shape, which is area of a triangle. Okay, we have told us that areas cover the surface of a given shape. So for a triangle, let's look at the triangle that we have here. We have a vertex. The vertex is the line that joins the base with the top angle of a triangle. So we have the height here and we have our base. Okay, so if we want to calculate the area of a rectangle, we have it to be half base times height. That is half multiplied by base multiplied by height. Where our b here, half b times a, b is the base and h is the height. Now, we want to look at area of a parallelogram. A parallelogram can be rearranged to form a rectangle as shown below. Now, let's look at it. Okay, so if we sketch a parallelogram, we can actually bring out a rectangle from it. Okay, by the time we draw a vertex in between, then we can have it in form of a rectangle. So a parallelogram can be arranged to form a rectangle that shown below. We made mention of that before. So if you want to calculate the area of a parallelogram, is base length times height. Look at this. This is the base, and we have this to be height. So we calculate area of a parallelogram as base length times height. That is formula for calculating area of a parallelogram. Now let's look at area of a trapezium. If you look at this trapezium, we can actually split it into two different triangle. Let's look at it. This is a triangle. We have triangle A, and we have another triangle here. We have triangle B. Remember, we have told us that the formula for calculating area of a triangle is what? Half base times height. Okay, so if we assume that, okay, for triangle A now, the formula is half base times height. Okay, then triangle B too is also going to be what? Half base times okay, height rather. So it's going to be half base times height. So if that is the case, now if you look at what we have here, for this one, the base for A is a small a, and that's why we have it to be A times H. And the base for B is a small letter B, which that's why we have B times H here. So by the time we collect the like times, now we have half in common, okay, and we have a H in common. So if we put that outside the bracket, then we can have it to be half times height into bracket A plus B, where our A and B are actually the base of the given shape. So let's have the area of our trapezium now to be half into bracket A plus B multiplied by what? Multiplied by height. Okay. Now let's look at some activities here. We want to calculate the area of this parallelogram below. We have told us that the formula for calculating area of the parallelogram is what? Is base length times perpendicular height. So look at what we have here. The base length is 8 centimeters here, and the perpendicular height here is 6 centimeters. So all we just need to do is use the formula, which is what? Base times h. That's what we're going to be using. So A, which is the area of the parallelogram, is now going to be 8 centimeters multiplied by what? 6 centimeters. 8 times 6 is 48, right? And 6 centimeters, since we are dealing with area, is going to be 6 centimeters squared. And that's the solution to that given problem. Now, let's fix the right answer into the boxes. Perpendicular height here is what? Is 6 centimeters, okay? So when we have 8 centimeters multiplied by 6 centimeters, it's going to give us 48 centimeters. And that gives solution to the problem. Okay, now let's look at another one here. We have to calculate the area of the shape below. If you look at this shape, we actually have a trapezium inside the shape, and as well we have what? We have a rectangle. So we are going to be calculating the two shapes, and from which we are going to be calculating the area of the shaded part of this shape, which is this shaded part. The shaded part here is green, right? So the first one here is let's calculate the area of the trapezium. The formula for calculating trapezium is what? R into A plus B, which are the base multiplied by height. Okay, so if you look at this here, our formula is going to be, our height is what? Our height here is 5, right? So the base is 3, and then we have 5 centimeters. So those are the base for that trapezium. Okay, so we have it to be R multiplied by 5. Remember, we said this is also going to be in centimeter. 3 centimeters plus 5 centimeters, that is what? 8 centimeters. So we have it to be half, okay? We have half multiplied by, okay? Now, if you multiply that, 8 times 5, that is what? 8 times 5 is what? That is 40 centimeters. Okay, but remember, we're having this centimeter square because we are dealing with area. Now it's going to be 40 centimeter square divided by 2, which is what? 2 can go in 40 and that is 20 centimeter square. And that's the solution for the area of that trapezium. Now let's look for the area of the rectangle, which is what? Area of the rectangle is what? L times B, that is length times breadth. The length here is what? Is 8 centimeter, okay, and the breadth is what? 12 centimeter. So 8 centimeter multiplied by 12 centimeter will give us 96 centimeter square. Now we want to calculate the area of the shaded part. So that implies that we are going to be subtracting the area of the rectangle from the area of the trapezium, which is what? What's the area of the rectangle? That is 96 centimeter square, okay, minus area of the trapezium, which is 20 centimeter square. 96 minus 20, that is 76 centimeter square. And that is the area of the shaded part. So let's fix the right answer into the boxes and let's see what we have. So 12 centimeter times 8 centimeter will give us 96 centimeter square, okay. The missing portion here are the base of the trapezium, which is 3 centimeter plus 5 centimeter. Now, by the time you have 96 centimeter square minus 20 centimeter square, then we're going to be having 76 centimeter square, okay? And that is this area of the shaded part of that shape, okay? Now, let's look at the next slide, which is circumference and area of a circle. Okay, so if you want to calculate circumference of a circle is just like we are dealing with the perimeter of a circle as well. And the formula for calculating that is 2 pi r. So that's the formula for calculating the circumference of a circle, 2 pi r. And for the area of a circle, the formula for calculating the area of a circle is pi r squared. So now of this our pi here is a constant value, and you can take a position of 3.142, that is a decimal point, or we have it in fraction as 22/7. And our r that we are talking about here is what? Is the radius. So our arrangement is right. Now we have this example here. We have to calculate the circumference of this given as circle. Now from that circle, we see that we have the radius to be what? The radius is 3 centimeter, and we have told us that the circumference of the circle is what? The circumference is 2 pi r. Remember we said that our pi r can take in form of 22/7 or 3.142. So we are going to be using 22/7 here, and let's see what we're going to be having. So it's going to be 2 multiplied by 22/7, okay, multiplied by what is the radius? That's 3 centimeter. Now, if that is the case, we have C to be 22/7 multiplied by 6 centimeter. Now, what is 22 multiplied by 7? Multiplied by 6 rather. 22 multiplied by 6 will give us 132 centimeter. Remember, we are dividing by 7. So if we divide that by 7, okay, we are going to be having what? We are going to be having 18.857.1. So if we were to approximate it to 3 significant figures, then it's going to be 18, okay, that should be 18.9 centimeter. So this is a calculator error anyway. So we have the formula to be what? Circumference of the circle to be 2 pi r. And by the time we multiply through, okay, since we are using decimal points here, then we have a decimal point error, which is 18.8 centimeter, based on the fact that we are making use of the pi here to be 3.142, and that gives us the solution to the circumference of that circle with radius 5 centimeter. Okay, now we have to calculate the area of this given circle as well. Now let's look at it. The area here is, the formula for calculating the area is what? Pi r square. Okay, now look at this. The area has been given to be what? To be 5 centimeter. So we have to give our first answer in 3 significant figure, and the next answer we have to give it in what? In exact form. That is, we are not going to be expressing the pi. So let's start with the first one. The area is what? Pi r square. Okay, so pi here, let's use the decimal point. We use fraction, which is 22/7 in the previous slide. So let's use decimal point here, which is 3.142. Okay, multiplied by the radius is 5 centimeter all square. Okay, that is what is 5 centimeter all square? That is 5 times 5, which is what? Which is 25. So we have 3.142. Okay, multiplied by 25. Okay, centimeter square. And by the time you fix it in pretty significant figure, we are going to be having 78.5 centimeter square as a area of this shape. Okay, well, if you want to, the other one said that we should express it in the exact form without expressing pi. So it's going to be, area is going to be pi r square, where our pi is we left our pi without expression. So we multiply it by the radius, which is 5 centimeter all square. So which is what 5 times 5 will give us 25. So we have 25, okay, pi, okay, centimeter all square. And that gives us the solution to this problem. So let's quickly check the arrangement here. The area of the circle is what? Pi r square. Okay. So by the time you multiply 3.142 times r 25, you have 78.5 centimeter square. And by the time we leave it in our exact form without expressing our pi, we have it to be 25 pi centimeter square. That solution to the past question. Let's look at the past question that we have here. Okay, we have to calculate the area of this trapezium. Remember, we told us that what's the formula for calculating the area of trapezium? Area of the trapezium is calculated as half into bracket A, okay, A plus B multiplied by H, which is height. So in this aspect, height is 5 centimeter, and the two ways we are dealing with here is 11 centimeter and 7 centimeter rather. Okay, so we have 11 centimeter plus 7 centimeter multiplied by 5 centimeter. That is 11. That 11 plus 7, that is 18 centimeter. Okay, multiplied by 5 centimeter. So 18 centimeter multiplied by 5 centimeter. I think that should be 90 centimeter. Now we are dividing by half, so it's going to be 1 times 90 centimeter all square. Now, since we are dealing with area, divided by 2, that is 90 centimeter all square divided by 2. 2 can go in 90 and that is 45 centimeter square. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.